Welcome everyone to Power Wheelchair Alternative Driving Methods, Proportional Controls. My name is Michelle Lang. I'm an occupational therapist in the Denver, Colorado area, and I'll be presenting this course for Stealth Products on this topic. I hope that this topic helps you in your role within the assistive technology field and with the clients who you work with. We have the following course objectives. 1. Describe the difference between analog and digital control. 2. List 3 different mini proportional joysticks and clinical indicators for each. And 3. Describe clinical indicators for joystick placement at the hand versus the chin. There are 2 handouts that go along with this course. First is a comparison chart of available mini proportional joysticks on the market, and second is Proportional Driving Methods Decision-Making Tree. We'll be using that somewhat as a basis for this course as we move through somewhat of a hierarchy of decision-making in determining the best proportional control for an individual client. So within this course, we'll be discussing some of the older driving methods that have been on the market for a while but have new features. We're also going to introduce some newer proportional driving methods, and again, using that decision-making hierarchy to help direct our clinical decision-making and match a client to the most appropriate driving method. There are a number of factors that have an impact on alternative driving method success. We're not going to get into those in this particular course, but make sure that you keep in mind that for someone to be successful in using one of these driving methods, they need to be positioned optimally. We always say that, but it really is critical. If someone's not positioned well, they may not be able to drive a power chair at all until that is addressed. So positioning is super critical to provide the support and stability that an individual needs. Next is a good old power wheelchair assessment where we dig in and determine, is this person a candidate for driving? Are they able to understand the task? Do they require more training or skill development? And then what equipment is going to best meet their needs? We need to keep in mind the drive wheel configuration, front, mid, or rear, as these directly influence the driving tendencies of the chair depending on the driving method. So for example, something like the head array may drive differently on a front wheel drive versus a rear wheel drive. Some of these alternative driving methods work better with certain drive wheel configurations. Tracking technologies, also very, very important. These maximize the efficiency of driving for an individual, reducing the amount of compensatory joystick movements or switch activations that are required to stay on course, particularly when that course isn't particularly smooth, such as over slopes or inclines or other varied terrains. Programming, very, very critical to optimize this drive for someone using alternative drive methods. And then finally, mobility training to allow someone an opportunity to maximize their driving abilities with that particular driving method. So with that said, let's jump into some of the available proportional driving methods out there. And again, we're going to talk about how we would decide on one versus another. So proportional driving methods are also referred to as analog driving methods, and these are primarily joysticks. There are some other methods as well. Proportional controls provide 360 degrees of directional control. So if you can move that joystick in a circle, that's what the wheelchair will do. Proportional controls also provide speed control in that the farther the joystick is deflected from center, the faster the chair will move. Versus digital or non-proportional driving methods where we have typically a switch that represents each discrete direction that the chair can move in, and when that switch is activated, the speed of the chair is unchanged. Now, most commonly, proportional controls are a joystick placed at the hand. Controlling a joystick is really more difficult than it appears. And I think it's important that we're aware of the requirements of using a joystick successfully so that if a client is unable to do so, we can maybe explain why to other team members. Proportional joystick control requires the ability to grade the force and distance of our movement. Well, what does that mean? It means that we have to use something called co-contraction to balance the activity in our flexors and our extensors. And this can be hard for people who have abnormal muscle tone. So let's say you're reaching out for your cup of coffee and you undershoot that cup or overshoot that cup. It's because you may have difficulty grading the distance of your movement. If that coffee is in a little styrofoam cup and you crush it or drop it, you might have difficulty grading the force of your movement, and that would translate over into difficulty with joystick control. So if the client does have the ability to grade the force and distance of their movement with their arm, they should be able to use a standard joystick. If not, we may have to explore other options, including digital access methods. We then have to ensure the client has adequate movement and motor control to reach out, grasp the handle of the joystick, and move it within those 360 degrees. If the client can, then we can explore again standard joysticks. If not, we may have to explore other options. We next have to see, can the client optimally control a standard joystick that is mounted at the end of the arm pad? If yes, we can typically explore a standard joystick. If no, we may have to explore alternative placements. Most joysticks are mounted right at the end of the armrest to one side of the wheelchair, usually the right side. And it's because most of us are right-handed and because it keeps it out of the way of transfers. The challenge is not all of our clients have optimal control in that exact joystick position. I think I know for myself, sometimes I'm guilty of trying to make a client fit the product rather than trying to modify the product to best meet my client's needs. And this is a situation where we can change that placement. So we can use a swing away joystick mount that allows more of a midline placement. These typically allow placement anywhere between end of arm pad all the way to midline of client. So we can choose the best location along that continuum. If it's not best between the right arm pad, let's say, and midline, well, we simply mount this to the opposite side, allowing us that full range of placement. These also allow a closer or more distant placement in relation to the client. The angle of the joystick can also be changed. So imagine you are pushing a joystick handle forward. You may not feel the most comfortable or have the best motor control pushing out directly forward from your body. Many of our clients tend to cross over their body when they're pushing forward to activate a joystick, and that can kind of jam them up when they're trying to drive. So we can change the angle of the joystick so that now when the client pushes forward, it matches the angle of their movement, and that improves their driving ability. So we can change this to a more oblique angle. Over to the right, you can see we can also angle the joystick box itself in a different plane, and this can accommodate pronation. Some people, as they are pushing towards that joystick, tend to rotate their forearm, thumb down towards the floor, pronation, and this can help accommodate that as well. The only challenge here is that someone's going to notice that this joystick looks crooked, and that drives people crazy. I think people are greatly fans of symmetry. So I have been known in certain circumstances to place a note on a joystick where I've needed to angle it and explain that I am actually doing this on purpose and please not fix it for me. If a midline mount is required, we need to determine if the client needs to independently move it out of the way. If so, we can explore power mounting options. If not, well, the caregiver can move the mount out of the way, particularly if they're needed to help with transfers anyway. It's difficult to justify funding for a power swing away mount for a joystick unless the client is capable of making that transfer on their own. At this point, the only power joystick mount on the market is from Motion Concepts, and you can see it here. The client needs to be able to activate the power mount somehow, typically by pushing a switch or button. They can then transfer out of the way and hop back in. And you can see this is using some stealth mounting hardware in this picture. Next in our clinical decision making is, does the client have difficulty grasping a standard joystick handle? Well, handles vary from manufacturer to manufacturer and on that particular style joystick, but we do have options of a variety of alternative handles that we can place onto a joystick. If the client does have difficulty grasping the standard joystick handle, it may be appropriate to explore these. So pictured on the right here, we have the mushroom joystick from Stealth, and it is designed for clients who have difficulty grasping a joystick handle. They can simply rest their palm over the surface of this mushroom-shaped handle. Now this can be a little stiff, meaning that it requires the same amount of force as a standard joystick. Some clients tend to slip off of this smooth surface, but there is a version of this available now that is dipped so that there's some texture to the handle to help the client keep their palm on that surface. Another option, BodyPoint also sells a dome handle, and this fits a variety of different manufacturers' joysticks. It has some texture on it to prevent slippage as well. BodyPoint actually has a number of alternative joystick handles that are available. Probably the one that I use most often is a goalpost style, and you can see two of those here. Those can be helpful for people with poor grasp because the hand can just simply rest within that goalpost, and the client can use movement of the shoulder and somewhat of the elbow to move this joystick handle. Although there are a variety of other joystick handles, I don't use a lot of other alternative handles because I find that most clients who are having enough difficulty with the joystick that we're exploring different handles, with the exception of that goalpost handle, most of those clients really are having difficulty with the joystick itself, and sometimes we simply need to explore other methods of driving. Does the client have excessive force which could break a standard joystick? If so, we can explore heavy-duty joysticks. If not, then we can stick with more of a standard joystick. So there are a few options out there. Switch-It, for example, has a heavy-duty joystick. It's actually not a proportional joystick. It is a switched joystick, and that's in an effort to improve the durability of the housing of the joystick itself, the inner workings of the joystick, to prevent breakage. A newer option is from Movis. Movis is out of Belgium and is distributed by Stealth Products. They have this all-round heavy-duty joystick, and it's designed for clients who use a lot of force. So most joysticks require about 250 grams of force to activate the joystick itself. This will respond up to forces as high as 650 grams and endure those forces, so quite a bit more force. It also has an enlarged throw, meaning that the client can push further than with a standard joystick, and that sometimes works well for clients who have a lot of force. One of the unique things about this heavy-duty joystick is it's retrofittable. So this can be placed on an Arnett or Curtis QLogic joystick. and retrofitted, and does make it more durable so the client is not likely to break the joystick itself. It does include a mini USB jack on it, a port, to allow for programming through the Movis software. All the Movis products are configurable. We'll talk about those in a little bit. It also includes 2 switch jacks, so that in addition to any switch jacks that may be present on the joystick itself, this retrofittable piece also has 2 switch jacks that can be used for power and mode. Since this is a programmable joystick, it's possible to get in that programming and reassign the functions of those switch jacks, just like you would on the programming of the wheelchair. So as I mentioned, Movis is in Belgium and is distributed by Stealth Products here in the United States. They have a number of alternative proportional controls, and we'll be discussing those throughout this course here today. Again, they do also come with their own programming software, so additional programming changes can be made on top of, in addition to, the manufacturer electronics programming. So next in our clinical decision making is there adequate room to mount a standard joystick where it's required for optimal control? So let's say we've decided this is the very best place for a joystick for an individual client, but perhaps the joystick is just too big. Joysticks are rather large, our standard joysticks, because they often include a display, power, speed controls. There's a lot of buttons and jacks and things on there, and as well as the handle itself. So if the client has enough room, we can use a standard joystick, but if there's not a lot of real estate there, we can also consider a compact joystick. So there are several options out there. These compact joysticks, for the most part, require the same amount of force and travel as a standard joystick. They just take up less room. Because they're smaller, we have to make sure that we've included a way of controlling features that are otherwise on the joystick, chiefly power and mode. So this is the compact joystick single switch, and it's from Adaptive Switch Labs, ASL. The top of this is textured, and that's designed so that the client can grasp the joystick easier without slipping off of it. Some clients tend to keep losing their grasp or their grip on a joystick handle. The top is also non-removable for clients who use so much force that they tend to throw this over their shoulder. There is one switch on top of the joystick handle, and that's designed as a reset switch or mode. There is a dual mode, dual switch version. There's 2 switches here on top, and there's 2 jacks on the bottom, and you can really send those switch signals wherever you would like to control whatever feature is required. So it could act as a mode switch, it could act as power, it could control other features too, as for example, a mouse click or directly controlling a tilt system. Movis, who we mentioned before, has their all-round joystick. The typical all-round joystick requires 250 grams. That's about the same as most standard joysticks. But there is a light version that requires about half of that. Like all Movis products, this includes a little mini USB port on it to allow for programming of the joystick itself. There are 2 switch jacks on the bottom of the all-round, and that is default set up for power and mode. There are built-in slots on the side. You have to remove these with a little tool, and you can place these twister switches in. These are just really nice, very ultralight mechanical switches, and these could be used, as I mentioned, for power and mode. As this is programmable, you can reassign what those switches control. You don't have to put the switches there. The switches could be wherever it best makes sense for that individual client for power and mode, but it's a nice option to build those right in. You can mount this for someone to control by their hand or by the chin. Again, looking at these little outriggers here, if someone had this by their chin, they'd simply pivot over to control power and mode, which is a nice option. Switch It, which is under the Sunrise Medical umbrella, has the Versa Guide and Versa Guide Easy. The Versa Guide requires about 240 grams, so again, similar to a standard joystick, and includes 2 switch jacks, which can be controlled by a mechanical or a proximity switch. And down here you can see these unusually shaped switches here are actually proximity switches, and they're plugged directly in the bottom. The Versa Guide Easy, like the all-round light, requires about half the amount of force as their standard compact joystick. These Versa Guides are compatible with QLogic and Arnett chairs. Sunrise Medical, as well as Permobil, both use Arnett electronics. So further down in our hierarchy here, does the client have the ability to grade the force and distance of their movement, as well as have adequate movement and motor control, but maybe not at their hand? There are some nice options out there that provide control by the foot. So let's take a look. There's actually 3 companies right now who make these foot-controlled options: Switch It, ASL, and HMC, which is under the Permobil umbrella. ASL, by the way, is underneath the Invacare umbrella, but any of these access methods that we're talking about are typically available on any manufacturer's chair. So just because ASL, for example, is underneath Invacare doesn't mean we can't use it on other chairs. Just because Movis is under Stealth, which is under Quantum Rehab, doesn't mean that a Stealth product can't be used on another manufacturer's chair. There are a few products that we're talking about here that only work on certain manufacturer's chairs, and when that is the case, I will definitely indicate that for you. So each of these basically work by taking a standard compact joystick and attaching it to a receiver. And then typically by pushing your toes down towards the floor into plantar flexion, the chair moves forward. By bringing your toes up to the ceiling in dorsiflexion, the chair moves rearward, and by pivoting the foot left and right, the chair will turn side to side. These work very, very well. One thing to keep in mind, though, is the few clients out there who can successfully drive with their foot may use their own unique pattern of movement to control a joystick, and it doesn't always match the pattern of movement required by these products here. I've only recommended foot control a couple times in my career over more than 30 years, and each of those times the client simply placed their foot on top of the joystick directly. We had to mount it down by the foot. We didn't use one of these particular products because the client had their own, again, pattern of movement. One joystick that sometimes works well for someone using foot control is the Mushroom joystick. It seems to have a good shape and level of durability for foot control. Next, does the client have adequate force to initiate and sustain joystick direction? If so, we can explore standard joysticks, but if not, then mini proportional joysticks may be helpful. So mini proportional joysticks not only are cute and small, but they require less active force and travel to activate. Standard joystick requires about 250 grams of force. Now that doesn't mean much to my brain, but in relation to that, many mini proportionals require about 50 grams of force, and some require about 10 grams of force. There's a few in between, but most of them tend to be clustered around this 50 grams of force or 10 grams of force. And the available mini proportionals are listed on your mini joystick comparison chart. The minis that require about 50 grams of force are often appropriate for use at the chin because we have more leverage at our head, and sometimes controlling something that's as sensitive as only 10 grams of force can be more difficult at the chin. Those really ultra-sensitive minis are often appropriate for use at a finger or thumb. Now, as we know, there's always clients who break the rules. These are just general guidelines. There's certainly clients out there that are going to do just fine with 10 grams of force by the chin or 50 grams of force by a finger or thumb. So, will the client use the mini proportional joystick by the chin? If so, then again, we may want to consider some of the mini proportionals that are somewhere in that 50 grams of force level, as these tend to work a little better by the chin. Mini proportional joysticks require less force than a standard or compact joystick, and that reduces the risk of repetitive stress injuries. Repetitive stress injuries are a combination of force and also repetition, that movement. When someone's driving with a joystick by their chin, there's a lot of movement at either the jaw or the cervical area of the neck, and it might be a combination of those two. That repetition can quickly lead to repetitive stress injuries. Now, if someone's using a joystick by their chin, we cannot reduce that repetition unless we change their driving method, but we can reduce the force, and that can reduce the risk of injury. So let's look at some of the mini proportional joysticks that fall in this 50-gram range. This is the Movis Multi joystick. It requires just about 50 grams of force, and it has 2 switch jacks on the joystick itself for mode and for power. Like all the Movis products, there's also a little mini USB port that you can see here on the box that's inline on the cable. This box also includes an additional mode and power switch. Because we have that little mini USB there, that allows us to use this for programming. So in addition to the power wheelchair manufacturers' available programming on their electronics, we can do some additional programming, and that includes reprogramming what those 2 switch jacks do. One of the advantages of having these switch jacks in line on this box is that now the wires can be further away for the client. So instead of having some wires hanging out right by the chin for power and mode, even though we can connect them to this other wire here, we can have them out of the way, maybe behind the client, and that can be really helpful. There's several different mounting options as well. We'll talk about mounting here in just a few minutes. The MicroPilot is by Switchit, and it's a unique joystick that's been around for a number of years in that it is isometric. So it doesn't respond to movement. There's very little throw to this joystick handle. Instead, it relies on force. It's actually adjustable and will rely on anything from 10 to 50 grams. So you can start quite sensitive. If that's a little too sensitive for the client, in addition to changing programming, we can also adjust the force mechanically on the joystick as well. Because this is isometric, it may result in less extraneous movements by the chin. So imagine you're driving with a chin joystick down the sidewalk. There's always vibration coming through the chair. There's some rocking and rolling happening on the chair too, between the chair and the environment, the surface underneath it. Some of that is taken care of by suspension on the chair, but not all of it. And if the client is moving around as a result within their chair in response to those bumps and jolts, they're going to be moving in relation to the joystick. That can lead to extraneous movement of the chair. Since this joystick handle doesn't move at all, this may result in less of that movement. This can also be mounted parallel to the floor. So if a client had better control of a mini joystick by a finger or thumb, by mounting this parallel to the floor, a client may be able to rest their hand on, say, a hand pad. We mount this mini joystick under the hand pad, facing directly out, and the client can flex their fingers. This gives people with muscle weakness more control and drive with the joystick in this position. Because it's isometric, that little joystick stem is less likely to drop towards the floor due to gravity. Many clients using a mini joystick by the chin may have difficulty with secretions, and moisture and electronics don't go along very well. There are several mini proportional joysticks that are completely sealed to protect the electronics from secretions as well as just dust and dirt and grime. An example of this is the ASL extremity control. It requires about 120 grams, so about half of what a standard joystick would require. Again, it's completely sealed. The Stealth Precision Mini Proportional Joystick, or PMP, is also sealed. You can see it here. It has 3 different handles to best meet someone's needs. iDrive is a line of alternative access methods that will work on any Power Wheelchair electronics package and can be programmed like our Movis line of proportional controls through the Power Wheelchair Programmer or separately through the iDrive software, either on a computer or a tablet. With our newer iDrive options, this is also Bluetooth, so programming can be done wirelessly. We don't have to plug into the iDrive CPU itself. So the PMP comes in both a standalone 9-pin version, but also in an iDrive version if we require this additional programming. Again, this is completely sealed. What if the client is going to use a mini joystick by their finger or thumb? Well, in this case, usually mini proportionals that require more like 10 grams of force work well by a finger or a thumb. There's less leverage by our finger or thumb than there is by the chin. So we have several different options of mini proportional joysticks that fall within this extremely sensitive range. First is the Molecule. And the Molecule is a newer option available from ASL. I don't have a picture of it on this slide here, where a magnet helps to return the joystick to center. So the client has to overcome the force, the resistance of that magnet to move the joystick away from center, but it will assist with the return. And it takes approximately 10 grams of force. The MEC, or micro extremity control, has been around for a long time. You can see it has 3 different handles here. This last one, this little mini cup sort of shape, can work well for a finger or thumb. It requires about 18 grams of force, and when the client pushes down on the top, it acts as a reset if the client has that ability. Some clients do well with this cork shape or cork type handle because it is less likely that the client will slip off of it. It provides some traction. However, it also can absorb fluids, and that can be a hygiene issue. And then finally, we have the Micro Mini. It is an isometric joystick, just like the Pilot, the Micro Pilot. So it responds to force rather than actual movement, travel of the joystick handle. The joystick handle is this little red dot here, and it's very similar to what we used to have on our older school laptops. It would sit in the middle of the keyboard and act as a mouse, and this uses the same technology. It can be mounted in a Stealth hand pad, as you see here. It can also be mounted on this rather unique ring mount if someone is able to control it in that way. HMC is now under the Permobil umbrella, and their mini proportional joystick has also been around for a long time. It requires about 13 grams of force. It's a great little joystick. One of the main challenges with this particular joystick is that it is not known to be very durable. Most of these mini joysticks are not too durable. It's important to protect them when we're mounting them from harm. If they get hit, if they get caught up during a transfer or hit in a doorway, they often will break. Because these are so very sensitive, it's also important, if possible, to get an attendant joystick for any caregivers, because someone of typical movement and force will not be able to drive with this, especially walking alongside of the client. They will either damage the joystick or damage some drywall as they careen that chair into the wall. Movis has the micro joystick that requires about 10 grams of force. It has two different handles pictured here. The second one has a little bit of an indentation in this spool shape, and that can help with finger or thumb access. It has two switch jacks only on the interface box, as well as that mini USB programming port. The reason for that is there's simply no room on this very small joystick for attachment of those switches for reset and mode. Again, since this could be programmed, those can be reprogrammed to do other features. And there's a variety of mounting options. So let's talk about that programming for a moment. Movis's programming software is called their configurator software. There's a lot of parameters that can be adjusted separate or in addition to the Power Wheelchair programming parameters. One of those programming parameters that I think can be very helpful with many proportional joysticks is road compensation. The wheelchair is going to automatically slow when encountering any uneven terrain. So let's say you're driving along and you're outdoors on a sidewalk, and all of a sudden that sidewalk gets pretty rough. If you're using a joystick, a mini joystick, which is extremely sensitive by the finger and especially by the chin, as your body starts bouncing around in that chair, the chair can be more and more difficult to drive. So the chair will automatically slow down until this driving surface smooths out. So it prevents that reduced control with those really sensitive joysticks under those circumstances. Now, if this gets in your client's way for any reason, you can always turn road compensation off, but it is one of the many proportional or programming options. We already took a look at the MicroPilot. This can be adjusted way down to 10 grams of force and works well at a finger or thumb. So again, requires almost no throw at all. It responds to force, and because of that, can be mounted parallel to the floor. I will sometimes mount this underneath a stealth hand pad. So again, the client can drape their fingers over the edge of the hand pad. That flexed position of the fingers can improve strength and control for people with muscle weakness. They also have a non-isometric version of their mini proportional joystick, and that's the Micro Guide, and it comes in at about 25 grams of force. So back to our clinical decision making. Does the client have difficulty using a joystick by the hand during cold conditions? Well, if the client does, and this is common in some clients with conditions like multiple sclerosis or Duchenne, we can actually use a hand warmer. Movis is one of the companies that offers a hand warmer. Again, for some clients with certain medical conditions, it's very difficult for them to use their hands if it is cold. So depending on the conditions where this person lives, the weather, if they're driving outdoors, this might place them in a position where they can't drive some of the day. So this hand warmer provides warm air around the joystick to continue driving. To get this funded, it's really important to stress the medical reasons why this person's diagnosis leads to difficulty with function, a decrease in function within a cold environment. One of the nice things about the Movis hand warmer is it recycles air from in front of the warmer so that it's not constantly heating up cold air from around the joystick. It's reheating the air that's already been warmed, so that reduces power consumption. It also has an optional hand hood, which keeps that warm air a little more contained by the joystick so that, again, we don't have a loss of heat. Because all the Movis products are programmable, we can program the hand warmer, which means you can choose a specific temperature that works well for the client, so it's not too hot, not too cold. You can even choose the speed of the fan. Now, if the client can control a mini proportional joystick by a finger or thumb, and the client wishes to hold the driving method in midline close to their body, we can explore an adapted game controller. This is from Switchit, and it's called the Drive Station. It can control the power wheelchair itself driving, seat functions, as well as mode changes. So basically, they've adapted a traditional game controller. These game controllers tend to already have mini proportional joysticks built right into them. So they've adapted this so that one or both of these can drive the chair. These built-in joysticks, depending on which game control is out at that time, require about 40 to 50 grams of force. There's also a lot of buttons on these. Now, these can't be programmed out in the field, but if you let Switchit know, hey, I want this particular button here to control my client's tilt, and maybe this one here to be a left click, you can do that. They will, they will go ahead and program that for you and ship it to you. Again, they can't be changed out in the field afterwards. This method works really nicely for clients who have Duchenne muscular dystrophy because those clients will start having more and more difficulty using a standard joystick as their muscle weakness progresses. But many of these teenage boys are still playing their video games because they have better control close in to their body. So the client can drive with this, just simply set it in their lap and do other tasks, pick it up, and continue driving. It could be mounted. The times I've used this with a client, typically they prefer to just hold it in their lap. And no, unfortunately, it does not go back and forth between driving the power chair and controlling true games. That would be wonderful, but at this time, once it's modified, it will only work with the chair. So let's talk about some mounting options because alternative access is awesome. It can really provide clients that we work with a way of being independent in their mobility. However, mounting is super important. We're not going to simply hand off most of these driving methods, perhaps with the exception of that game control. It needs to be mounted in a way the client can control it. So let's talk about mounting by the chin. We have two main options. We can either have a swing-away mount that stays in position relative to the wheelchair. The mount is attached somehow to the wheelchair itself, perhaps off of a head support or off of a back cane or the seating system. If the client is moving around within their wheelchair seating system, they're going to move in relation to the joystick. If we use a bib or harness mount that actually is worn by the wheelchair driver, it will stay in position relative to the client. So if the client is moving a bit, even moving in response to movement of the chair over varied terrain, the joystick is more likely to stay in position. The main drawback of wearing the mount is the client can't get the joystick readily out of the way if they're not driving, like during meal times. If the client needs to move the mount independently, there are two power mount options like we talked about for standard joysticks, and this is a modification of a swing-away mount. So let's start with those harnesses and bibs. So we know there's clients that need the joystick mounted at the chin. So we need something to hold it there. And if we use a harness or bib, it keeps the joystick in alignment with the client, even if the client is bouncing around in their chair a little bit, but again, does not readily move out of the way. Typically, someone else is going to have to help the client get this on and off. Depending on the harness or bib, there's varying degrees of adjustability. That adjustability is really important. We could have 20 different people driving with a joystick by their chin, and the exact placement of the joystick is going to vary quite a bit from person to person. It might be just in front of the chin, might be under the chin, might be even a little behind the chin, depending on where that client has the most control. The angle of the joystick might be different from person to person. So it's important to make sure we have adequate adjustment for that individual to get the joystick in the right placement. These harnesses and bibs, for the most part, can accommodate most of the mini proportional joysticks that are available on the market. A newer option from Stealth is the iDrive control harness. You can see here there's quite a bit of padding on the portion that goes over the neck. That's important. Some of these mounts are heavier than others. This is a little on the heavy side, and it's important to improve that comfort and pressure distribution. There's also an optional chest strap that goes behind the client's back to try to keep this harness in position. And we have lots of adjustment depending on how many links you put here, and those can be adjusted quite readily by a tool or by this knob, this lever here. We can adjust some of the movement and place that joystick just where the client needs it. This will also support various outriggers if we needed to also place a mode switch, for example. We do have two power options at the head for mounting a chin joystick, and that includes Motion Concepts that's posted here on top, and the Movis Multi-Swing, which is pictured here at the bottom. These work well not only for mounting a mini joystick by someone's chin or a compact or even standard joystick, but also sip and puff, any control that's by the mouth. These can be used to hold hydration like the tubing of a CamelBak, or even a very lightweight device like a tablet or some of our smaller standalone speech generating devices. The placement of this can be adjusted, and the Movis Multi-Swing is, again, programmable. So we can program the speed, we can program whether the movement of the swing away requires a switch to be held down to sustain movement, or if the switch only has to be activated momentarily to initiate the full movement of this swing away mount. One of the nice things about the Movis is it gives you an option of where this mount moves. So instead of the mount only moving to the side, which is shown with the Motion Concepts mount, it can also move straight up and over the client's head. And that means it'll swing out of the way even if the client maybe is next to something where the Motion Concepts mount might get in the way. And again, in addition to those bibs and the power swing away options, we also have other swing away mount options using a variety of hardware. Stealth, for example, has swing away hardware that can be attached to a head support or elsewhere on the chair that can support that mini joystick mounting. If we are mounting by the hand, we can use mounts such as these shown here, but it's important to make sure that the forearm, the wrist, and the hand are well supported on an arm trough or tray, because people using these mini proportional joysticks by a finger or thumb generally have muscle weakness. It's really, really important to provide that postural support for this person to be successful. We don't want the client trying to hover in space over this little joystick. So these pictures are awesome, but just imagine pictured along with this, that postural support. We have to ensure the joystick itself is mounted in the optimal position. We can do so by utilizing a hand pad that provides some adjustment to us. We can also add in midline or swing away mounts, again, such as pictured here. I use the Stealth hand pad quite a bit with mini proportional joysticks. I use a lot of mini proportional joysticks by a finger or thumb with the clients that I work with. What I like about this is several things. First, it protects the joystick itself. So here's that HMC joystick, notorious for being rather fragile. Most of the joystick is now protected underneath this hand pad. And if my client is not driving so well and hits the side of a doorway, this tray, this little hand pad, is taking the hit, not the mini joystick. And that's super important. I can also adjust the height of the mini proportional joystick, which is great. So it can be protruding above the level of the tray. It can be flush with the tray. Wherever my client has the best control, it's going to depend on how they place their hand in relation to the hand pad. The hand pad itself provides support to the hand. Now in this picture here, we're still kind of out in space a little bit, but this pad can be placed at the end of this arm pad, or a arm trough on a swivel perhaps can be used to line up with this hand pad if this is a better position for the client. We can also use this Eclipse tray here, and we can go ahead and mount a mini joystick within the tray. Again, changing the height of the joystick in relation to the tray surface. This tray pivots on its hardware, so we can place it to be underneath the arm at the correct angle that the client needs to optimize their control of that little mini proportional joystick. So what is our take-home message on proportional controls? Well, there are a lot of ways to drive a power wheelchair, and we're going to have an additional course on those non-proportional driving methods in the Stealth library as well. Remember that positioning, drive wheel configuration, tracking technologies, programming, and training all optimize driving for an individual. So these are equally as important as choosing the right alternative driving method. We might pick the very best driving method for someone, but if these other issues are not addressed, the client may still not be successful in their driving. So keep in mind, we're going to have some other recordings in the library that can be helpful to you, including non-proportional power wheelchair driving methods, power mobility assessment, and pediatric power. Thank you very much for attending our course here today. I appreciate your time, and I encourage you to check out the course review questions, which will help reinforce the content that we've reviewed here today. Contact information for Stealth products and for myself listed here. Feel free to check both of these out. I have some resources on my website that might be helpful for you as well if you're looking for more information about power mobility. Again, thanks everyone.